Now, without further ado, I would like to now welcome our first speaker, Jim Thomas, whose bio has already been posted in the chat. We won't read bios because of time. Now, Jim, please welcome, and please share your screen and start off with your presentation.
Great, and I hope everybody can see my slides. As Sabrina says, it's my task here to present this new briefing, Box Biotech, which is a sort of short introduction to the question of the integration of artificial intelligence and synthetic biology, what's being called generative biology. And I really do want to thank the African Centre for Biodiversity, who really showed great foresight in commissioning this work, along with etc. Group and Third World Network, and also the reviewers, particularly Dr. Maya Montenegro of UC Santa Cruz and Dr. Dan McQuillan from Goldsmiths College in London. One thing I would really like to emphasize is that this report is just a briefing. It's an introduction. It's a sort of a preliminary scan of the issues that are raised. And that's because there isn't yet a deep dive, significant report that's looked at the many policy issues, equity issues, sustainability issues that are now raised by these new developments in so-called generative biology. And there urgently needs to be that. And such a study needs to happen under the aegis of trusted international bodies, such as the Convention on Biological Diversity. And luckily, that's exactly the option that's in front of the Conference of the Parties, the 16th Conference of the Parties in Cali next month, the option to actually commission an in-depth assessment on the potential impacts of the integration of artificial intelligence and machine learning into synthetic biology. This is something that's urgently needed. This technology, this integration is moving very fast into commercial use. For those who may not know some of these terms, synthetic biology is a term that's used to broadly describe the next generation techniques and approaches to genetic engineering. It tends to refer to more experimental approaches, newly emerging technologies, and honestly is very often a sort of a hype term that mobilizes capital and investment, but also research agendas. And the underlying concept behind synthetic biology is to try to make the somewhat messy world of biology more predictable, more rational, more of an engineering substrate, programmable even. And so there's a lot of metaphors in the field of synthetic biology, like programming DNA as code or life as machines, which make strong, powerful metaphors, but are problematic in terms of obscuring some of the complexities and messiness of building a world. And of course, because this is a term that's often used for mobilizing money, there's a tremendous amount of hype. We're talking about techniques such as genome editing, synthesizing new DNA and RNA or proteins, and so forth. If the field of synthetic biology is full of hype and obscuring metaphors, then even more so the topic of artificial intelligence. And I think it's important to recognize that artificial intelligence as a term covers a whole basket of computational technologies used for data analytics, forecasting, natural language processing, and so forth. And most importantly, what we're not talking about here is the science fiction version of artificial intelligence. This is not thinking machines, intelligent computers, computer sentience. What today passes for artificial intelligence is sets of computation that calculate probabilities and then make sort of predictions. And they're often trained on extremely large sets of data that are then interrogated in order to make these kind of predictions. There are different types of artificial intelligence. I'm not going to talk about traditional AI. Discriminative AI is the sort of AI system that takes large amounts of unstructured data and is able to look within it and sort of recognize patterns. For example, to look at pictures and recognize that there's a cat there. And generative AI, which is much of what we're going to be talking about, also depends upon taking large sets of data and then building a model which can generate similar types of data basically. This is the kind of AI that you have that says, not recognize a cat, but draw me a picture of a cat or write me an article about a cat. And it creates synthetic data in a predictive way, rather in the way that your phone will make predictive text. It will try and work out what you want and present it to you. The reason why generative AI is so much to the fore is that there is a massive investment boom right now around these generative AI systems, really sparked by the coming out of Chat GPT at the end of 2022. Now we see hundreds of billions of dollars being sunk into the generative AI space, with the hope by investors that they're going to get very real outcomes here. So far, and we've seen Goldman Sachs and others point out, these hundreds of billions of dollars are really not yielding anything very much. And so there's a hope by moving into synthetic biology and other areas, they'll yield a bit more. In the report, we lay out 4 different areas where artificial intelligence is combining with synthetic biology and biotech. And I'm going to focus mostly on the first of these, generative biology, the use of artificial intelligence for biodesign. And what we're talking about here is asking an artificial intelligence model to come up with new strands of DNA or new protein sequences that might not have existed before. And I'll talk more about that in a moment. But it's worth noting that also use of artificial intelligence can improve machine vision and laboratory processes or fermentation and bioproduction that we're seeing, for example, in digital agriculture, the combination of living organisms being modified alongside AI, and that's we call biodigital convergence. And we're even seeing artificial intelligence computation being carried out in an experimental way in living cells, for example, brain organoids. So there's a biocomputation part to this. Biodesign and generative biology, which is mostly what we're going to be talking about, sits on a very simple idea. If you use Chat GPT, you'll know that that's an AI model which is trained on millions, even billions of pieces of text, such that you can say to it, write me a poem about a dog, and it will write you what looks like a poem about a dog. Or you can get something like Midjourney, and you can say, draw me a picture of a dog, and it will draw on the millions of images that it's been trained on to draw you a picture of a dog. And so the idea of you can take one of these generative AI models and train them on millions of digital sequence information about genetic resources on DNA and RNA, then you can also say, design me a protein. And as Jason Kelly here of Ginkgo Bioworks puts it, the idea is to make an AI model that can speak protein or speak DNA, just like ChatGPT speaks English. The poster child for this, a sort of proof of principle, is a program that's very high profile called AlphaFold, developed by DeepMind, which is Google's AI section. And in about 2017, 2018, AlphaFold was trained on many thousands or ultimately hundreds of thousands of sequences, protein sequences. The sequence that of RNA that is then folded into a living protein. And by 2021, DeepMind were claiming that AlphaFold could work out how every single protein that is known, every protein sequence folds into actual proteins. And this solved supposedly what is called the protein folding problem in biology. That an AI was able to do what takes many years for a human scientist to do. And this was really held up as a major leap forward for big science and for AI-driven biotechnology. The excitement over Google AlphaFold is also about the fact that now we can get an AI to begin to control or predict the living world at the molecular level. But it's worth raising a bit of a red flag here, while there's a lot of excitement at the lab bench, protein scientists are saying, well, wait a minute, these are just predictions. As is true of much of AI, this has to be checked. And in fact, we're seeing a large number of errors in what AlphaFold is predicting, and limits and even hallucinations, which I'll come to soon. And so AlphaFold, even though it's held up as this wonderful example of using AI to solve biological problems, actually was very much overclaimed. And this is something we've seen, whether it's with gene editing or even generative AI, these instant overclaims, and then need to sort of row back on that. One metaphor that we've leaned on heavily in this briefing, and it's important to understand if you're not familiar with debates around artificial intelligence, is the concept of the black box. Basically, the black box problem, which is much discussed in AI policy, refers to the fact that when you train an AI model and then it makes outputs and decisions, it does so sort of hidden away in a black box. It's not possible to understand why it made decisions that it made. It's just simply too complex. And the black box problem of not being able to have explainability, this opaqueness, causes real problems for policy and in this case, for outcomes. It means that humans have been cut out of the loop on decision making and deciding why particular genetic sequences are used. It has serious implications for safety and accountability and traceability, and I'll come back to that in a moment. Another common topic in AI policy that's very relevant here is the notion of hallucinations. And this is when you have an AI model, for example, supposed to produce images, and those images look okay, but when you look closely at them, you find that they have all sorts of errors, or AI text that is full of errors. So here we have an old man who, when you look closely, has impossibly long right arm and 6 digits on his hand, being impaled by a unicorn. This is because of a hallucination by the AI image system. And analysts have estimated that AI systems will hallucinate about a third of the time, and about half the time there's some kind of error within their results. This is quite significant, and it's significant when you're talking about text and images. It becomes extremely important if you've got hallucinations occurring in living organisms or within biological molecules. Scholars have pointed out that this isn't the system not working properly. This is the system working properly. And this is actually baked into how generative AI works, and have suggested that generative AI systems should be scientifically classified as bullshit machines. They just make something that kind of looks right, but they're not fundamentally interested in finding truth. There are also very serious issues around bias that we refer to in the report, and that has to be brought into considering the use of AI for building synthetic organisms. In the report, we touch on some of the biological molecules that AI systems, generative AI systems, are now being asked to generate. These are novel biological molecules, new synthetic proteins that would never have existed before in nature, new strands of DNA and RNA. And each time the decision making on how to order those genetic codes or those protein codes is hidden. It's hidden in the black box. There's also companies that are building new gene editing proteins. People will be familiar with CRISPR-Cas9 as a system, but there are companies like Profluent who are now creating new AI-generated gene editing systems, or indeed ways of changing the epigenetics, things like histone modification, the ways in which genetic systems express themselves. That's also being redesigned through artificial intelligence. One of the things we focus on in this short report is how much big tech, big digital tech, is embracing this shift to putting together artificial intelligence and synthetic biology. A recent high-profile book on artificial intelligence by Mustafa Salman, who was in fact one of the founders of DeepMind and is now the head of Microsoft AI, really is focused on this question of how artificial intelligence and synthetic biology are creating, as he says, one of the most profound moments in history. Well, that's a lot of hype, but it is significant. And we're seeing some clusters of of work by very large digital tech companies. Google, of course, because of their work on DeepMind, on AlphaFold, have their own generative biology company called Isomorphic Labs, but are also working with probably the leading synthetic biology company, Ginkgo Bioworks, to produce synthetic versions of flavors and fragrances and food ingredients. Microsoft have their Microsoft GPT platform, and OpenAI, which is largely owned by Microsoft, is working with Los Alamos Lab on these issues. Amazon is also working with a generative biology company called Evolutionary Scale, and they have a model called ESM3. But interestingly, the Bezos Earth Fund, which is by Amazon founder Jeff Bezos, has put $100 million into using artificial intelligence for climate and nature, but largely focused on synthesizing proteins for food. And other companies such as NVIDIA, Salesforce, Meta, Tencent, Alibaba. These are literally the world's largest and best capitalized companies who are all going fully into this area. So I wanted to end by touching on 5 urgent challenges that this commercial rush into generative biology raises. And I was part of the multidisciplinary ad hoc technical expert group on synthetic biology that began to look at this topic earlier this year. And very quickly, the issues that that group started to identify were about biosafety. Of course, if you're producing new DNA strands and so forth that have hallucinations in it, then we have a worry about safety. But in fact, many on that group who were biosafety assessors pointed out that as assessors, if the decision making over how to make these new proteins and DNA was done in a black box, they have no data to work with to do safety assessments. And that's very significant. So the black box is obscuring the ability to do biosafety assessment. The military planners have also pointed to something called the pacing problem. Briefly, in the same way, we're now seeing large amounts of synthetic pictures and text coming out of ChatGPT that's overwhelming the internet. What happens when we start to see large amounts of synthetically produced, artificial intelligence designed living organisms that may overwhelm biosafety regulators? Probably the issue that I found most concerning, however, was this. It was about biopiracy. As I've mentioned in passing, in order to have these models, you first have to train them on massive amounts of what's called digital sequence information. A company like NVIDIA, here there's a quote from NVIDIA saying that for their Gen SLM platform, they took all the DNA data for DNA and RNA data for viruses and bacteria, about 110 million genomes, learned a language model over that and can now ask it to generate new genomes for profit. That's a massive utilization of digital genetic sequences. And because this is all done in a black box, there's no traceability back to which sequences are being drawn on to create the new genomic sequences, protein sequences, and so forth. You've lost traceability. You have this massive utilization for commercial uses. And this gets away from the core principle that the Convention on Biological Diversity has worked on, the idea of fair and equitable access and benefit sharing, the idea that we trace where genetic sequences come from, and then when they're used for commercial and other purposes, there are benefits go back to those original stewards of biodiversity. By having this in a black box, that's lost. And just to emphasize, every single one of these models requires that massive amounts of data is training this genetic sequences. And that massive amount of data is increasing. We now have companies, I think there may be people here from Basecamp Research, who are now trying to get new genetic sequences to enlarge the amount of data going in. So this is very important. We're going to hear a lot of promises around the fact that the use of generative biology could create new drugs, new proteins for so-called sustainable foodstuffs, for sustainable biomaterials, and that this may help the sustainable use of biodiversity to reduce fossil fuel uses and so forth. But that has to be put in context. These systems, these generative AI systems, are incredibly energy hungry. The computation required at the moment is using up energy on the scale of, say, the country of Sweden, electricity, but also massive water use, which of course is being extracted from agricultural systems and so forth. And of course, massive use of minerals, silicon, copper, and so forth. And so it will maybe at the end of the day, we find that use of these systems actually puts too much pressure on biodiversity. There are concerns about how you can not just produce new plastics or new drugs, but you can also produce new viruses and new toxins, and this has to be dealt with through the biotechnology, the Weapons Convention. And finally, one of the core tasks of the Convention on Biological Diversity is the commitment to respect, preserve, and maintain the knowledge, the innovations, and practices of indigenous and local communities. Much of what is being promised on the promises side is to be able to make new sweeteners, new proteins, new flavors, new fragrances, and these will directly replace those that have been stewarded by, grown by, looked after by indigenous peoples and local communities, and change the underlying economies that these communities depend upon. I'm going to leave it there. Others will have important things to say, and I really encourage you to look at this new report on the AC Bio website. Thanks very much.
Thanks for the invitation, and also thanks to everybody who's here today with us. And so I'll be happy to share a couple of reflections on what is arguably one of the most critical technological developments in global environmental policy and beyond at the moment. Now, as Jim has mentioned, under the Convention on Biological Diversity, for the last 1.5 years, we have had an expert process, the ad hoc technical expert group on SynBio, where Jim and Osama and myself had been involved. And that group has flagged the integration of AI and machine learning into SynBio as one of the 5 priority issues that warrants further close looks and potentially also regulatory action. And perhaps a strong indicator of the overall relevance of that topic is that in all the discussions in that group, where a lot of different perspectives on a lot of different things existed, was that there was never really any doubt that this topic, AI and machine learning in SynBio, is critically important. And now, of course, as with all of the other items that we looked into, which also included gene drug systems, and a couple of others, there was a lot of debate on how to weigh the potential positive impacts versus the potential negative impacts, but also on the question what kind of governance implications flow from these technological developments. But there was always broad consensus that what Jim back then, I remember that expression, called the biodigital convergence, is crucially important to the future of global biodiversity governance and the CBD. Now, of course, just as with the term synthetic biology, artificial intelligence and machine learning are quite slippery concepts. And on one hand, this also indicates that there is a need for more conceptual and definitional work to try and pin down what exactly it is that we're talking about here. But the fuzziness of these terms also in some way reflects that the technological fields in question here are moving very quickly and are moving targets, and it is very difficult to pin them down conceptually in a precise way. And that also relates to what we often refer to as the pacing problem, that technology often develops more quickly than governance institutions can adjust. Now, as with most new technological developments, we are seeing a bit of an ambiguous mix between opportunities and challenges. From a governance perspective, the problem is that we don't really know the ratio between opportunities and challenges. From a perspective of biodiversity governance, is this a primarily positive thing? Is this a primarily problematic thing? And what if there is, in principle, no way of even answering that question? What kind of governance choices should we make in that case? Now, as Jim has also noted in his briefing paper, there are a couple of areas where, in principle, we could see positive effects for biodiversity. So one of them that is frequently mentioned in the debate is the use of AI and synbio for the creation of new materials that could perhaps reduce the pressure on natural resource systems and thus contribute to sustainable use. But there are, of course, also questions of biosafety, as Jim mentioned, with the black box problem, which also complicates the risk assessment for new genetically modified organisms, because in the end, we don't really know how the algorithm is producing a specific genetic sequence. And of course, there are also broader concerns that go beyond biodiversity policy into the realm of biosecurity. For around 20 years, we've had this debate to what extent new technological developments in do-it-yourself biology lead to the threat of non-state actors cooking up terrible pathogens in their garage. And if we're essentially at the point where you could use a simple text prompt to generate a genetic sequence for a deadly microorganism and then use commercial DNA synthesizers to actually produce the genetic sequence, then that also is not likely to make the world a safer place. Now, however, I believe perhaps at the moment and in the context of the CBD, the most urgent issue relates to the problem of digital sequence information. And this is in many ways a very familiar story that we've been seeing now for about 40 years. Input factors, which is in this case genetic sequence data, are supposed to be open access and available free of charge, whereas outputs, which means advanced AI models or products that are developed via those AI models, are proprietary. So this is something that in different contexts has been going on for 4 decades, and for almost as long we have been seeing attempts at the international level to come up with governance solutions to ensure some degree of fairness and equity, not just under the Convention on Biological Diversity, also under the UN Food and Agriculture Organization, under the World Health Organization. We're having similar debates on the use of digital sequence information in the context of vaccines development for pandemic response. So it's a pretty big debate. And I think it's also important to recall that 2 years ago, COP15 agreed that the benefits from the use of digital sequence information on genetic resources should be shared fairly and equitably. Now, as we are moving forward, the key question is, how do we ensure that technological development in SynBio and AI is consistent with, or perhaps even supportive of, the provisions of the CBD and its protocols? So as we are moving into COP16, we need to bear in mind that the current approach to SynBio under the CBD is based on 2 linked components. On one hand, there is to be a focus on technology transfer, on capacity building, and on knowledge sharing. And the ad hoc technical expert group on SynBio has already also flagged that there is profound inequity between North and South in the capacities to use, to regulate, to monitor, but also to adopt, leverage SynBio. And so in that context, it's also worth noting that there are a couple of provisions of the CBD, including Article 16 on access to and transfer of technology, or Article 18 on technical cooperation, that are clearly relevant as we are moving into the Kali meeting. On the other hand, there is also a need to expand and to deepen the process that the CBD has created on broader regular horizon scanning, monitoring, and assessment in order to identify and to analyze new developments in synthetic biology, including in relation to artificial intelligence. And those two larger components are intrinsically connected with each other. So you need horizon scanning, monitoring, and assessment to clearly identify potential positive and potential negative technological developments, which then feeds into the broader question of which technologies should be transferred, which kinds of capacities should be built, and so on. Because clearly, if we are looking at technological developments that offer opportunities for sustainable use or biodiversity conservation, then the question of capacity building is quite different from technological developments that mainly present biosafety issues. So to conclude, at COP15, we have seen quite a bit of momentum on digital sequence information and on synthetic biology. And it's now really up to COP16 to carry this momentum forward. As Jim also noted, there is a lot of commercial activity. There is a lot in motion in the technological field. And we simply do not have the luxury of waiting until COP20 or 25 to kind of to find a solution to this issue. Thank you very much.
Thank you so much, Florian, for that follow-on from Jim. So our next presenter will be Osama.
Okay, so thank you all for being here today. Let's start by discussing the integration of two of the most transformative technology in modern science, artificial intelligence and synthetic biology. Actually, the opportunities are immense by combining AI with SynBio. We open the door to revolutionary innovations that can advance capabilities in a wide range of fields. However, with these opportunities come challenges. AI simplifies many complex biological processes, making advanced synthetic tools more accessible. But this accessibility also lowers the barrier for misuse by less experienced or even malicious actors. We need governance frameworks that can keep pace with this development, ensuring we manage and regulate this technology responsibly. On the biosecurity and cybersecurity threat side, let's consider the risks starting with biosecurity. AI could potentially be used to design new pathogens or biological agents, which greatly increase the risk of misuse, whether intentional or accidental. The ability of AI to identify virulence factors, for example, and create novel pathogens raises the possibility of catastrophic global events if such agents are mishandled. On the cybersecurity front, AI systems used in synthetic biology are vulnerable to hacking. If unauthorized actors gain access, they could steal or manipulate sensitive genetic data, undermining the safety and integrity of biological design. This presents significant global safety risk that has never been before. Next, we must acknowledge that some unforeseen consequences of integrating AI into synthetic biology. One of the biggest challenges is the black box nature of AI. This lack of transparency can make it difficult to understand how certain biological designs are generated, complicating risk management and regulation. Without clear insight into AI output, it becomes harder to anticipate and mitigate risks. Moreover, as we increasingly rely on AI, there is the danger of eroding traditional biological expertise. Reduced human oversight may limit our ability to effectively identify and manage emerging biological risks. Also, we have the unexpected effect on biodiversity and health. The environmental impact of AI-driven synthetic biology could be profound. New organisms created by AI might not have any existing comparators, making their ecological effect unpredictable. These organisms could interact with native species in unexpected ways, potentially disrupting ecosystems, particularly in biodiversity-rich regions like Africa. On the societal and ethical concern, so in addition to risks that are scientific, there are significant societal and ethical concerns. AI in synthetic biology is blurring the line between natural and artificial life. This raises important ethical questions, such as what level of risk is acceptable and what safeguards are necessary. We need clear ethical standards and boundaries to guide responsible innovation. Furthermore, we must ensure equitable access to the benefit of AI-driven synthetic biology. We need to be mindful of the risk of exacerbating environmental inequality, and it's essential to promote the fair distribution of benefit and burden across communities. We also need to highlight that existing regulatory frameworks are not sufficient to handle the unique challenges posed by AI-driven synthetic biology. We need to adapt our policies to keep pace with the evolving nature of these technologies. In addition, robust ethical framework must be developed to ensure responsible innovation with a focus on transparency, accountability, inclusivity, and sustainability. Safeguarding genetic resource and digital sequence information from exploitation is also crucial, along with ensuring fair benefit sharing agreements. When it comes to risk assessment, we need new methodologies that are capable of evaluating and managing both known and unforeseen risks. This includes designing effective containment measures to mitigate any adverse impact. We also need robust surveillance and monitoring systems to track the deployment and effect of these technologies. This system will ensure that any adverse event or unintended consequences are detected early, allowing for timely response. For Africa, these issues are especially critical. It is essential that we safeguard the continent's rich genetic resource and ensure that any benefit derived from AI-driven synthetic biology are shared fairly. A people-centric approach is vital. Governance and equity must be addressed to maximize the benefit for both nature and community. At the same time, we need robust regulatory framework in place to manage and regulate this emerging technology effectively. The stakes for Africa are particularly high. We face the risk of data monopolization, where large corporations control digital sequence information, potentially sliding African contribution. The opaque nature of AI algorithms also complicate effective regulation and oversight. We must ensure that these technological advancements do not widen the global inequity gap. Africa should benefit equally from this innovation, and it's up to us to develop the governance mechanisms that will ensure this outcome. Thank you.
I'm very happy to be here and to be with all of you to share some thoughts about this issue. And what I'm going to speak about specifically is really to look at some of the convention's obligations and linking them to the need to responsibly assess the integration of artificial intelligence and synthetic biology. So one of the first questions that you might ask when you first saw this webinar being announced might have been, well, what interest does the CBD have on artificial intelligence? Is it within the scope of the CBD? Well, of course, we're all familiar with the discussions around AI and the applications, especially such as ChatGPT now, generating novel text, images, and videos. And of course, we know also about the mistakes therein, as Jim pointed out regarding the hallucinations that might occur. And at the same time, there are also actually many multilateral discussions taking place on policy and governance issues in regard to AI, including at the UN General Assembly and through the Secretary General's high-level advisory body on artificial intelligence. Now, at the CBD, what we're interested in really, or what we're concerned with, is really the integration of AI and synthetic biology. And as Jim has explained very clearly, there is this new wave of generative AI developments that are focusing on generating novel digital sequences for GMOs and proteins, what is called generative biology. And we know that the technology is also there already for automated bots to redesign and engineer life building blocks. Now, AI and synthetic biology acting in tandem could actually speed up the generation of modified AI-generated life forms, which would likely have not existed before in nature. So basically, we're talking about GMOs or LMOs on steroids, right? Now, if the tech lives up to the hype, then there could be a significant increase in the overall number of new life forms and proteins being produced and possibly entering the market or ecosystems. So this calls for increased human capacity, right? To regulate, to monitor, and to undertake biosafety assessments. And there will also be greater uncertainties that will need to be addressed, particularly when we're thinking about the black box, as Jim has pointed out. Now, the previous speakers have helped make the case for precisely why the CBD should be governing and responsibly assessing the integration of AI and synthetic biology. So I'm going to just try and make the links with some of the specific provisions of the CBD, which actually provide the frame for international governance and regulations of new technologies that may negatively impact biodiversity. Now, of course, we know in the first place, one of the CBD's founding principle is really the precautionary approach, which is rooted in Principle 10 of the 1992 Real Declaration on Environment and Development. Now, that approach is enshrined in the CBD. It's a fundamental, foundational principle, and it's also operationalized particularly through the Cartagena Protocol on Biosafety. So as highlighted by previous speakers, using AI to digitally design genetic systems may actually move this process of genetic engineering into an unknowable so-called black box, where individual design decisions can be neither traced nor explained. And the increased uncertainties are precisely why the precautionary approach is needed. As precaution is applied when there's lack of full scientific certainty about the extent of potential adverse effects, and then precautionary measures or actions can be taken to avoid or minimize such potential adverse effects, even when there's not yet full scientific information or knowledge. Secondly, the integration of AI and synthetic biology may have profound implications for biosafety and impacts on biodiversity and health with the attendant socioeconomic risks, as Jim also alluded to at the end of his presentation. So then parties need to be able to identify and anticipate upcoming developments, to anticipate potential adverse effects, and to monitor and assess the integration of the impacts of AI and synthetic biology. And these are precisely the purview of Article 7 of the CBD on identification and monitoring, and of its Article 14 on impact assessment and minimizing adverse impacts. For example, paragraph B of Article 7 stipulates that parties are obligated to identify processes and categories of activities which have or are likely to have significant adverse impacts on the conservation and sustainable use of biodiversity, and to monitor their effects. While Article 14 obligates parties to either require environmental impact assessments of projects or to take into account the environmental impacts of programs and policies, and all with a view to avoiding or minimizing the adverse effects on biodiversity. Now, these articles really, Article 7 and Article 14, are really about horizon scanning and monitoring, which is Article 7, and assessment of impacts, which is Article 14. Now, this is a term we've become very familiar with in the synthetic biology discussions, and this is also why the issue of the integration of AI with synthetic biology was one of the priority trends assessed by the multidisciplinary ARTSEC on synthetic biology, which was, as both Jim and Florian explained, established under the CBD and has worked in the last couple of years on various trends. And precisely the issue of AI and synthetic biology was identified as a key one that needed urgent attention. Now, thirdly, and more specifically, because the integration of AI and synthetic biology could generate modified AI-generated life forms, these modified organisms then become the subject matter of specific provisions of the CBD, in particular Article 8G and Article 19. Now, Article 8G obligates parties to regulate, manage, or control the risks associated with the use and release of living modified organisms, or LMOs, resulting from biotechnology, which are likely to have adverse environmental impacts that could affect the conservation and sustainable use of biodiversity, and also taking into account risks to human health. those who are familiar with the Cartagena Protocol on biosafety, of course, Article 19, paragraph 3 is the precursor to that, triggers the regulation of LMOs resulting from biotechnology. And you'll be familiar, of course, with the terms that the CBD and the Cartagena Protocol don't just look at conservation and sustainable use of biodiversity, but also take into account the risks to human health and also considers socioeconomic considerations. So that's quite a much more holistic approach than what may sometimes be purely thought of as scientific risk assessment. Paragraph 4 of Article 19 also requires the sharing of information about the use, about safety regulations, and of potential adverse impacts of such LMOs. So these are very relevant to the discussion around AI and synthetic biology. And of course, as we fast forward to 2022, we now have the Kunming-Montreal Global Biodiversity Framework, and Target 17, the biosafety target, essentially calls on parties to establish, strengthen capacity for, and implement in all countries biosafety measures as set out in Article 8G. And the KNGBF, as the so-called Master Plan of Biodiversity to 2030, it has to be future-proofed. It has to be equipped to deal with new developments, such as the integration of AI and synthetic biology. Fourth, we have the link, of course, between the precautionary principle and the polluter pays principle of the Rio Declaration. And this is, for example, expressed in Article 14, paragraph 2 of the CBD, which obliges parties to examine the issue of liability and redress, including restoration and compensation for damage to biodiversity. And of course, a very pertinent exemplification of liability and redress is the Nagoya Kuala Lumpur Supplementary Protocol on Liability and Redress to the Cartagena Protocol. And liability and redress issues are, of course, central to what we're discussing today, because if damage occurs, there must be a way to exact compensation from those at fault and to provide redress to victims of the damage. And in addition, response measures may need to be taken to deal with environmental damage if there is, or even if there is sufficient likelihood of damage. And the Supplementary Protocol on Liability and Redress sets some of these provisions out quite clearly in relation to LMOs, and could also be applied arguably to organisms that arise from AI and synthetic biology. Now, my fifth point is really around the issue of fair and equitable benefit sharing. As we heard from Jim, generative biology relies upon massive use, and I would say arguably the theft of digital sequence information, or DSI, on genetic resources. Some people have called this digital biopiracy because the resources that are stewarded by communities, by indigenous peoples, by small farmers, now, researchers don't necessarily have to access physical materials anymore. They can just use sequences, which are uploaded, which are shared in private public databases, for example. And this is really has many implications for the third objective of the convention, which is the fair and equitable sharing of benefits arising from the use of genetic resources, and is the subject matter of the Nagoya Protocol and Nexus of Benefit Sharing. And when we come to talking about AI and SynBio in particular, because of the use of digital sequence information, the current discussions on the multilateral mechanism for fair and equitable benefit sharing arising from the use of DSI and genetic resources should be cognizant of these new developments. And a key question is how do these developments in artificial intelligence affect the ability to share benefits fairly and equitably? Now, all these features of generative biology really challenge current biosafety assessment capabilities. They potentially undermine monitoring requirements and remove traceability required to ensure the fair and equitable benefit sharing from the use of DSI and genetic resources, and also undercut systems of liability and redress. So there's a real potential that this integration that we're talking about of AI and synthetic biology could potentially undermine the very foundations of the CBD. So the issue is really something that CBD parties cannot afford to ignore. And they need to be able to, of course, firstly separate the hype from reality. As we know, there is a lot of hype around the technologies. We need to see what is actually reality. But secondly, because of the increased amount of investments going into generative biology, and as Jim has shown, many of big tech companies are now jumping on this bandwagon. We need to be able to properly understand the implications, be able to assess them properly, and be able to be ready to govern, to regulate these developments. So I just want to quickly turn to what can be done and what is currently on the table for COP16. Now, and this is largely based on the recommendations of the multidisciplinary ARTEC on synthetic biology, because on the table, but still in square brackets, are the option to continue the in-depth assessment that was already kickstarted in the last intersessional period. COP parties could take up the recommendations to initiate a policy formulation process addressing the integration of AI with synthetic biology. And the elements of this would include requesting the ARTEC to conduct further assessment, which would lead to a report on the potential impacts, including social, economic, and cultural impacts. And I think it's very important to highlight that the assessment would not just be on a scientific risk assessment, for example, but has to be a wider and broader assessment of the full spectrum of potential impacts. Secondly, to ask the Secretariat to produce a technical publication series addressing AI, which of course would then look at the literature and systematize this and synthesize this, and participate in UN system-level activities concerning AI governance, as well as convey the results of this process under the CBD to these multilateral fora. Importantly, parties the recommendations is for parties to consider what kind of effective and equitable governance arrangements are needed, and what the implications of the integration of AI and synthetic biology are on the three objectives of the convention, of course, including the DSI issue. And just to very quickly mention here, of course, and I think it's also highlighted in the report, many big tech firms and generative biology companies train their AI models on DSI. And there have to be modalities to ensure that these corporations actually account for fair and equitable benefit sharing, because the communities, the countries that have provided the resources are often not receiving any benefits, whether monetary or non-monetary. And in the case that corporations are utilizing DSI, including at a commercial level, it should be subject to the multilateral mechanism and the obligations to pay into the DSI Global Fund. Now, this sector is included in the documents coming out of the DSI working group as one that uses DSI, but no agreement yet has been reached on the question of how payments will be collected and from whom. So all these under square brackets at the moment. Now, I'll just end by saying that the impetus and responsibility really is on CBD parties to address this fast developing issue and to ensure that the CBD maintains and strengthens its oversight. And this must include through precautionary measures that address the risks and uncertainties of generative biology, and actually the full spectrum of biosafety, horizon scanning and identification, impact assessment of environmental, health, socioeconomic risks, monitoring, liability and redress, fair and equitable benefit sharing. These provisions and these elements are actually embedded in the CBD and its protocols. So the question then really is that will CBD parties act to ensure that these new developments are brought under equitable and effective governance oversight. Thank you very much.
Welcome, and if you have a presentation, please share it.
Bonjour à toutes et bonjour à tous. Comme ça a été dit en introduction, je suis un petit paysan en France et j'ai représenté la Via Campesina internationale comme observateur depuis 2007 à toutes les réunions de l'organe directeur du traité international sur les semences, et notamment à son groupe de travail sur le système multilatéral de partage des avantages, ainsi qu'à quelques réunions de la Convention sur la diversité biologique. Et donc, je remercie les organisateurs de m'avoir invité à cet échange aujourd'hui. La biologie de synthèse, comme ça a été montré, s'appuie sur de larges utilisations des informations séquentielles numériques et de l'intelligence artificielle. Si la biologie de synthèse fait partie des biotechnologies modernes définies par le protocole de Carthagène, l'intelligence artificielle et les informations séquentielles numériques ne bénéficient à ce jour d'aucune définition convenue. Cela permet à l'industrie de choisir des définitions différentes suivant les diverses enceintes du droit national au sein desquelles elle exerce son lobbying. Les pays du Nord qui soutiennent l'industrie prétendent ainsi que les informations séquentielles numériques ne sont pas des ressources biologiques soumises aux obligations de la CDB et du traité, mais qu'elles sont des produits de la recherche. Et dans les enceintes chargées de la propriété intellectuelle, ils soutiennent l'inverse, puisque ces enceintes considèrent que la portée des brevets portant sur ces informations séquentielles numériques et les caractères associés à ces informations s'étend à toutes les ressources biologiques qui les contiennent et expriment leurs fonctions. Donc, on ne peut pas dire qu'elles ne sont pas une composante génétique de ces ressources biologiques. Il profite pour cela de l'étanchéité conceptuelle actuelle entre, d'une part, la Convention et le traité, et d'autre part, les accords internationaux sur la propriété intellectuelle. Les textes qui seront soumis à la prochaine conférence de la Convention, fin octobre, reconnaissent qu'il est impossible, sauf de rares exceptions, d'établir le lien entre les DSI qui sont désormais en accès libre sur Internet et les ressources biologiques au sein desquelles elles ont été identifiées. Cette impossibilité résulte d'abord de l'absence de traçabilité entre ces DSI et les ressources initiales au sein desquelles elles ont été identifiées, mais aussi du fait qu'une même séquence génétique peut se retrouver dans de multiples ressources biologiques différentes. Cela entraîne deux conséquences. La première, la fin du partage bilatéral des avantages. Ce partage d'avantages est devenu impossible entre le bénéficiaire et le fournisseur primaire de la ressource biologique, puisque on ne peut plus l'identifier. C'est pourquoi la Convention s'oriente désormais vers un système multilatéral de partage des avantages qui serait abondé par un pourcentage de toutes les ventes des entreprises des secteurs économiques qui utilisent les informations séquentielles numériques, la pharmacie, les semences et bien d'autres, que les ventes soient, que ces entreprises aient ou non utilisé les informations séquentielles numériques. Lors de l'adoption du traité en 2005, plusieurs millions d'échantillons de semences étaient déjà disponibles dans les banques de gènes internationales, la plupart sans traçabilité de leurs origines. C'est pourquoi le traité a adopté un système multilatéral d'accès facilité et un fonds de partage, lui aussi multilatéral. Mais les obligations de paiement à ce fonds ont été systématiquement contournées par l'industrie. Pour ceux qui suivent le traité, je ne développerai pas cela ici parce que je n'ai pas le temps. Mais la conclusion, c'est que il a été abondé bien en deçà de ce qui lui est dû, uniquement ou essentiellement par les dons de quelques pays riches et de fondations philanthropiques dont le rôle est de redistribuer et d'orienter l'utilisation des produits de la défiscalisation des bénéfices de l'industrie. Je veux parler de Bill Gates et d'autres fondations de ce type. C'est pourquoi le traité envisage désormais un système de paiement assez proche de celui que propose la Convention. Ces nouvelles propositions semblent donc aller dans le bon sens. Mais elles ne disent pas qui seront les bénéficiaires de ces nouveaux fonds de partage des avantages, puisque les paysans, les peuples autochtones et les communautés locales qui ont fourni les ressources biologiques ne sont plus identifiables. L'expérience du fonds de partage du traité fournit une réponse. C'est celui qui paye qui décide. Donc, je l'ai dit tout à l'heure, celui qui paye, ce sont les pays riches, quelques pays riches, et des fondations industrielles. Le fonds de partage du traité finance donc des chercheurs et des ONG qui sont payés certes pour soutenir les paysans qui sélectionnent et conservent leurs semences, mais à la seule condition de collecter ces semences pour les verser aux collections du système multilatéral et de recenser et de publier les connaissances de ces paysans associées à chaque échantillon de semences. Un échantillon de ressources biologiques et les connaissances associées sont les principales données qu'utilisent les puissants outils de l'intelligence artificielle à disposition des seules grosses entreprises pour identifier les liens entre certaines informations séquentielles numériques contenues dans ces ressources biologiques et leurs fonctions. Cela permet à ces entreprises d'introduire ces informations génétiques dans de nouveaux organismes biologiques au moyen des biotechnologies modernes qui sont toutes brevetables afin de pouvoir revendiquer de nouveaux brevets portant sur ces DSI et sur leurs fonctions. C'est ainsi que la deuxième conséquence, c'est que le partage multilatéral des avantages devient un instrument de biopiraterie. L'accès libre sur Internet au DSI supprime aussi l'obligation de consentement préalable libre et éclairé de la CBD qui permet aux paysans, aux peuples autochtones et aux communautés locales de s'opposer à tout droit de propriété intellectuelle limitant l'usage des ressources qu'ils ont fournies. Cet accès libre supprime également l'engagement contractuel du bénéficiaire de l'accès à une ressource phytogénétique du système multilatéral du traité à ne revendiquer aucun droit de propriété intellectuelle limitant l'accès à cette ressource, ses parties et ses composantes génétiques. Mais la plupart des brevets portent actuellement sur des organismes génétiquement modifiés par les biotechnologies modernes dont la traçabilité est rendue obligatoire par le protocole de Carthagène. C'est pourquoi l'industrie et les pays du Nord global veulent exclure les nouvelles techniques génétiques brevetables des biotechnologies modernes définies par le protocole. Cette expulsion des biotechnologies modernes provoquerait en effet la suppression de l'obligation de publication de l'identifiant unique qui permet de distinguer les OGM brevetés de tout organisme non issu de l'invention brevetée, y compris ceux qui contiennent naturellement les informations séquentielles numériques couvertes par ces brevets. Or, aucun paysan, peuple autochtone ou petit sélectionneur n'utilise, ni ne connaît, ni ne publie les informations séquentielles numériques Compte tenu dans les ressources biologiques qu'il a sélectionnées et conservées, il n'en dépose pas non plus des échantillons dans des collections officielles. En cas de poursuite pour contrefaçon de ces brevets, ils ne disposeront dès lors d'aucun moyen de prouver qu'ils n'ont pas utilisé l'invention brevetée. Ils se verront donc interdire de continuer à utiliser les ressources biologiques qu'ils ont fournies gratuitement au système multilatéral. La même menace pèse aussi sur tous les paysans et sélectionneurs traditionnels dont les récoltes ou les semences sont contaminées par des gènes brevetés sans qu'il n'y ait aucun moyen de s'en prémunir. Il en sera de même pour les animaux d'élevage, les algues et les micro-organismes naturels utilisés pour les soins des plantes, pour les sols, les soins des animaux et pour la transformation des aliments. En conclusion, que pouvons-nous faire face à ces menaces? Tout d'abord, continuer à faire ce que les paysans ont toujours fait, que ce soit autorisé ou non, sélectionner, utiliser et échanger leurs propres ressources génétiques selon leurs propres règles et non selon les règles des multinationales et des États. Mais l'accès libre aux informations séquentielles numériques, désormais irréversible, impose aussi d'obtenir très rapidement l'interdiction de tout droit de propriété intellectuelle portant sur des organismes, leurs parties, leurs composantes génétiques. Droits de propriété intellectuelle s'ils ne sont pas accompagnés de la publication de l'identifiant unique qui permet de le distinguer de tout organisme qui n'est pas issu de l'invention justifiant le brevet. Mais évidemment, la seule solution durable, notamment aussi par rapport au problème de contamination par des gènes brevetés, reste l'interdiction de tout brevet sur le vivant. Cela implique, au-delà des discussions à la CDB et au traité, des changements aussi à l'Organisation mondiale du commerce et à ses accords sur la propriété intellectuelle, et des changements à l'Organisation mondiale de la propriété intellectuelle. Tant que ces changements ne seront pas réalisés, nous devons rejeter toute modification des textes actuels de la Convention sur la diversité biologique et de ses protocoles de Nagoya et de Carthagène et du traité. Et ce combat, pour conclure, doit être mené à la fois au niveau global, dans ces diverses enceintes, et dans les lois nationales. Je vous remercie de votre attention.